Alright, so we're going to do some origami. I love origami, and hopefully we can use it throughout the year. So if you've never done origami before, one of the things that is good to remember is you're always going to make better folds if you fold on a flat piece of paper. So we don't want to pick up our paper and fold it. We want to keep it on the ground. So the first thing you're going to do, you're going to pick a nice light color paper, and you're going to take this lower corner and bring it up so that it matches this upper corner, and this side is as close as possible lined up. This side is as close as possible lined up. And so when I lined it up, I kind of pressed it down here and then made my fold. Okay? So I fold my square in half diagonally, and then I open it up, and I'm going to move this diagonal down here. We've got a nice negative slope. What's the slope of that line? Hopefully you said -1, right? So I'm going to take this lower corner, and I'm going to move it up here. I want to go past the middle, but I want this crease to make a line to follow that line. So I want these two edges to be parallel and these two edges to be parallel, as close as possible. Because if I do that, I'm actually making a square. This turns out to be an isosceles triangle. On the other side is another isosceles triangle. I add those together, I'm going to get a square. Okay? So now this part's a little tricky. You're going to take your ruler. You're going to put the ruler up against the edge of that square. Leave a little bit of room for the pencil. Try to keep it straight. Doesn't have to be perfect. And then lift the square. And then draw a line. The line is going to be approximately marking the edge of that square. It's probably not going to be perfect, but close enough. Do the same thing on this side. Take the ruler, put it up against that space, and then draw a line. So now I have something like this. And here is my other square. Okay? So I have two squares. Looks like this. It turns out, if I had done this perfectly, these two rectangles would be the same size. And what size would they be? Well, I'm going to label this side as A. This is my big little square. And the area of that little square is going to be, I'm waiting, A squared. Okay. This bigger side, I'm going to call these sides B. B, 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 B. And it turns out from some properties of rectangles we'll learn later in the year, this is also going to be B. And this is also going to be A. This is going to be B. And this is going to be A. So my square has sides A plus B. Using my segment addition postulate that we're just learning, this segment A plus this segment B, if I add them together, I get a segment that's A plus B. Okay? And the area of this bigger square is going to be what? It's got a length of B and a height of B, so the area is going to be B squared. Now I'm going to take a colored pencil just to add some color to this. And I'm going to draw a line. I'm actually drawing the hypotenuse of this triangle that's got A and B for legs. It's a right triangle. This is a right angle. If you need to, you can write in the little square there to remind yourself that that's a right angle. So I've got two triangles here with a hypotenuse of C. Same thing down here. I'm going to draw it like this. Okay, that's my C, that's my hypotenuse. Okay, now what's the area of these triangles? They're all for the same side. Remember that the area of a triangle is 1/2 base times height. If you forget that, think about the area of a rectangle, which is base times height. And how much of that rectangle is the triangle? Half of that, right? So this triangle is half of the rectangle. So the area is 1/2 AB, where A is the base and B is the height. And that's true for all of these triangles. Okay. So now, we've accounted for every single area on this piece of paper. So to get the total area, we just have to sum everything up. Sorry about that. So, I've got my total white area is going to equal this piece, A squared, plus this piece, which is B squared, plus 1/2 AB plus 1/2 AB plus 1/2 AB plus 1/2 AB. I add all those together is 2AB. And if you want to check your algebra, this is a square that's A plus B on both sides. So it turns out this equals A plus B squared. Right? A plus B times A plus B. Base times height. And if you want to do that to review your algebra, remember when we FOIL things, so first times first, A squared. Outer times outer is AB. Inner times inner is AB. Last times last is B squared. So that's going to turn out to be A squared plus 2AB plus B squared. Okay? The last thing that we're going to do, we're actually going to finish this up on Friday, when hopefully you're going to be here. And so all I'm going to say is take this right there, take this right there, and fold it along that line. Okay? I'm going to finish it up just in case you can't get caught up on Friday. Okay? Remember, this is C. This side is C, so I'm going to mark that here. I'm going to mark it here. This length right here is C. This is A, and this is B. Now, this is a little tricky. I'm going to fold this corner up so that this edge lines up with this edge. So it's going to look like that. And I'm going to go all the way around. And yours is going to look a little different. If you made your rectangle exactly in the middle, you won't have much of a hole in the middle. Mine is not perfectly lined up, but that's okay. It's close enough for what we need here. Okay. So now look at what I have. I have a square, and that square Every side of that square is C. Okay. So I want to take my ruler, and I'm going to try to use this pencil. Sometimes the pencil doesn't write very well on the colored part of origami. Ugh, I just broke the lead, proving that I was correct. So I'm just going to use a normal pencil to outline that square. I learned this proof actually after I became a math teacher, and when I first saw it, I thought it was pretty magical, so hopefully you like it. So now we're going to do the same thing we did on the other side. We're going to figure out the area of this square, which has a base of C and a height of C. So it's going to have an area of, I'm listening, yeah, of course, C squared. And then we're going to look at these four triangles, and we're going to get their area, just like on the other side. Each of those has an area of 1/2 base times height, so that's 1/2 A times B. So area equals 1/2 A times B. Area equals 1/2 A times B. Area equals 1/2 A times B. Okay? So the total colored area equals C squared plus 4 of these triangles is going to be 2AB. But we know the white area and the colored area are the same. So colored area equals white area, which means C squared plus 2AB equals, from the other side, A squared plus B squared plus 2AB. And when we have the same term on both sides of the equal sign, we can just lift them off. So what do we end up with? C squared equals A squared plus B squared. And that's our Pythagorean theorem. So again, I want you to have this in your composition book, so you can kind of look at it, take some time till you really understand what we've done. And this is what you're going to do. So first, fold it back up as a square. And then where you have this diagonal, fold that. Okay? And then come back to your original drawing, and this is what we're putting in the pocket. It should fit right in there. So then you're going to put it in your pocket. You have your proof of the Pythagorean theorem, the explanation of the Pythagorean theorem, and we're going to do some problems with this on Friday. So I look forward to seeing you. I hope this helps. And this was fun for me. I've never done this before. So thanks for watching.